Hello guys, and welcome to another video. So here we'll be looking at a multiple choice question, and it reads: red light of frequency f and wavelength shines on an object. The red light is then replaced by a light of a higher frequency. How do the frequency and the wavelength of light shining on the object now compare with that of red light? Okay, for us to answer this question, guys, we have to firstly understand the relationship between frequency and wavelength, and we say that relationship is inversely proportional. So now we are told that this red light is replaced with a light of higher frequency, and if that light is having a higher frequency, that means that if the frequency of that light has increased, the wavelength has now decreased. Now they are asking us, how does that light shining on the object now compare with that of the red light? Well, first of all, we'll say that that light is going to have a greater frequency, and if that light has a greater frequency, it should also now have a lesser wavelength. So our answer is going to be greater than frequency. So the light shining on this object will be having a greater frequency than that of the red light, and it will have a lesser wavelength than that of the red light. That's how we answer this one. And now let's look at our question 3. It says the electromagnetic spectrum includes, amongst others, radio waves, ultraviolet light, gamma rays, and X-rays. And that they say list 2 properties of electromagnetic waves. There are a lot of them, guys, but the first one that we can talk about is the fact that electromagnetic waves originate from accelerating electric charges. We can also talk of the fact that the electromagnetic waves travel in a vacuum, and lastly we can talk of the fact that they travel at a speed of light that is 3 times 10 to the power of 8. So those are the answers that we're going to give. Any of those 2 will suffice. So these are going to be our option. As you can see, that electromagnetic waves originate from accelerating electric charges, they travel in a vacuum, and they travel at a speed of 3 times 10 to the power of 8 meters per second. So any of these 2 answers, any 2 of these 3 answers will work. Now let's move on to the next one. 3.2 says arrange the above 4 waves in order of decreasing wavelength. Okay, for us to answer this question, guys, 3.2, what we are going to say is that Ronaldo's mother is visiting Uncle Xavier's garden, and we know that when we move from radio waves to gamma rays, we are increasing in frequency, right? And if we are increasing in frequency, it means we are decreasing in wavelength. So here we have how many spectrums? We have radio waves, we have ultraviolet light. We have ultraviolet light, we have X-rays, and we have gamma rays. So we will remove these other ones, and if I'm arranging these by the order of decreasing wavelength, I will start with the radio waves, and then ultraviolet light, and then I'll have X-rays and gamma rays. That's how my answers will be, because radio waves have the longest wavelength, and then it is followed by the ultraviolet, the X-rays, and then the gamma rays. So yeah, these are your answers for 3.2: radio waves, ultraviolet rays, X-rays, and gamma rays. Now let's look at 3.3. It says which of the above electromagnetic waves has the greatest penetrating ability? Give a reason, and this is how we'll answer that question. Again, guys, to answer this question, we go back to Ronaldo's mother is visiting Uncle Xavier's grave. Yes, we go to Ronaldo's mother is visiting Uncle Xavier's garden. Radio waves, microwaves, infrared visible light, ultraviolet light, X-rays, and gamma rays. And we know that as we move from radio waves to gamma rays, our frequency is increasing. So the answer to this question is going to be that gamma rays have the largest frequency. They have the highest penetrating ability rather, and the reason is because of what? It's because of them having the highest frequency. Okay, that's how we'll answer this question. So yeah guys, that's how you answer. You will say gamma rays because they have the highest frequency. We know that if you have the greatest amount of frequency, then you will also have the greatest amount of penetrating ability. That's how you answer that question. Now we move on to the last one, 3.4, and it says a photon of ultraviolet light has 1,33 times 10 to the power of negative 18 joules of energy associated with it. Calculate the wavelength of this wave. Firstly, I'm gonna write down our two formulas. All right guys, these are our two formulas, but remember that this one we use when we are given what? Frequency, and this one we use when we are given what? The wavelength. So this is the one that we'll work with. Okay, this E is equal to hc over lambda. That's the one we will work with. So I will write it down to say E is equal to hc over lambda. And then I will substitute now. I know that this h is a constant of 6,63 times 10 to the power of negative 34, and this c is also a constant, which is our speed of light. This h is the Planck's constant, and the c is our speed of light, which is 3 times 10 to the power of 8, and we will divide everything by our we are looking for the wavelength guys. So that means for the E we will substitute by saying 1,33 times 10. Okay, I don't have space there, let me just fix. Okay, so where we see E, we are gonna put the energy there because that's our energy measured in joules. So we will have 1,33 times 10 to the power of negative 18 is equal to our Planck's constant times the speed of light. There they are, and at the bottom we'll have our wavelength, and then from there we do the math. So what I'm gonna do is to say this energy is over 1, and then I'm gonna cross multiply. When I cross multiply, I'm saying this 1,33 times 10 to the power of negative 18 multiplied by the wavelength, and the answer I'm going to get is 1,33 times 10 to the power of negative 18 lambda. All of this will be equal to 1 multiplied by all of this. So this guys I'm gonna put on the calculator as it is, then we'll get our answer. Let's do it. So when I multiply the Planck's constant with the speed of light, the answer I'm getting is 1,989 multiplied by 10 to the power of negative 25. And then from there, I'm going to divide by the coefficient of the wavelength, which is 1,33 times 10 to the power of negative 18. And this I'm going to do on both sides. Times 10 to the power of negative 18. Then these will cancel. Therefore, the wavelength will be equal to, I'm going to take this and put it on the calculator as it is. All of this, put it on the calculator. And when I say this number divided by this one, the answer I'm getting is going to be 1,495 times 10 to the power of negative 7 meters. So this is my wavelength, basically this one. Let me quickly show you how you mark all of this. So what you are going to mark, guys, is the formula. Then you'll mark the substitution of your energy, mark the substitution of your Planck's constant and the speed of light, and mark the final answer, and you get your 5 marks. Quite easy to get these 5 marks. I'm done with this video, guys, and if there's something you didn't understand, you'll just play back the video, rewind it, and then play it all over again, and hopefully eventually you'll understand. See you on the next one.